Alright, looking at this particular problem, we're trying to find the charge on the metal M. So if we look at our two compounds, we have M, OH2, and M, CO3. Well, the charge on OH is -1, and the charge on CO3 is 2 negative. Since I have two negatives over here, I have to have a +2. I have two negatives here, so I have to have a +2. So M must be a +2 ion. B. In standard conditions, the concentration of pH is 9.5. And the question asks us to first, in I, find the concentration of the OH. So, pH equals 9.15. That means the pOH has to equal 14 minus the pH, which equals 14 minus 9.15, which is 4.85. So now I have the pOH. To find the OH concentration, that has to equal 10 to the minus pOH power, which is 10 to the minus 4.85, and we calculate that we come out to be 1.4 times 10 to the minus 5th molar. Alright, second question. Write the solubility product for the expression. So we have to write an equation first. So M OH2 yields M2 plus and 2 OH minus. So the Ksp has to equal the concentration of the M2 plus times the concentration of the OH minus squared. And the last thing we need to do is to calculate the value for the Ksp. So using this equation that we have up here, we know the OH is that value. So Ksp has to equal something times 1.4 times 10 to the minus 5th squared. Well, if we look at the mole ratio, I see that I have a half of mole this compared to that. So if I could take this number, 1.4 times 10 to the minus 5th, and I can divide that by 2 to find the value for the M2 plus. So if I calculate all of that, again getting my calculator out, I get a Ksp of 1.4 times 10 to the minus 15th power. So in part C, which we'll do over here, we've already calculated the molar solubility of the M2 plus, or the MOH2, is equal to 1.4 times 10 to the minus 5th divided by 2, which is 7 times 10 to the minus 6. So now we have to find the solubility of the MCO3. So doing the MCO3, I know that the Ksp is given as 7.4 times 10 to the minus 14th, and it has to equal the concentration of M2 plus and the CO3 2 minus, and both of those, since it's a 1-to-1 ratio, has to equal X. So 7.4 times 10 to the minus 14th equals X squared. So if I solve for X, I will get 2.7 times 10 to the minus 7th power. And that's a molarity too. This was a molarity, I should have written that there. Now I need to compare these two values, this one and this one. So, since 7 times 10 to the minus 6 is greater than 2.7 times 10 to the minus 7, the solubility of the MOH2 is greater.